Now we are doing an example of factor analysis on European value study data with Varimax rotation algorithm. We start as usual with loading the data. We have discussed the variables previously. First thing we have to do is to drop the titles of variables which are in the first row in our table. So we forget here about the first row. And then we look at histograms. And what we see is that all the variables should be measured on the scale from 0 to 10, and what we see are negative values here. Those negative values are different encodings of missing data. Some of them just mean that the data were not collected. Some of them mean that a person refused to answer. What we have to do is to remove all those missing data, and this is what we do here. We started with 59,000, a little bit more, 59,500 of rows, which means 59,000 of people. And after removing missing data, our table contains 47,317 rows, each for one person answering our questions. Now when we look at histograms, we see that the values are as they should be from 0 to 10. Next steps is, because factor analysis is done on standardized data, so this is what we do. We calculate means for all the 9 variables, we calculate variances for all the 9 variables, and finally we standardize our data. On standardized data, we can calculate covariance matrix, which is in this case the same as correlation matrix because variables are standardized. And then we diagonalize this matrix, which means we calculate eigenvalues and eigenvectors. Our eigenvalues are here. I will make it boldface and slightly bigger. And our eigenvectors are here. We will, based on eigenvalues, we will choose how many factors we want. One of the criteria says that we take factors corresponding to eigenvalues which are bigger than 1. This means 2 factors. However, there are also other criteria. For example, we may want to explain roughly 80% of the total variance in this model using our factors. However, for that we calculate the cumulative number of the cumulative percentage of variance explained by factors. However, to reach 80%, we will have to use 1, 2, 3, 4, 5, 6 factors, which is definitely too many. So we will probably abandon this particular criterion. Another criterion is associated to the scree plot. We are looking for the elbow in the scree plot, and the elbow is here at the third factor. So it means that we either can use 2 factors or 3 factors. We will see which will be better. We start with 2 factors. First, we calculate factors. The factors will not be needed later because we are just doing factor analysis and don't use the results to some further statistical calculations. So what we really need are loadings. Here we calculate loadings, and we look at loadings factors. The numbers that are in this matrix, these numbers have the meaning of correlations of factors. This is about first factor, this is about second factor, with our variables. And what we see here is that there are lines like this one. Both factors correlate quite strongly with the seventh variable, and similar situation is with the first variable. Both factors correlate rather strongly with the first variable, which means that rotation of factor is in order. This is our not rotated picture. These are our loadings presented as points on the plane. Each row has two coordinates, first factor for x coordinates, second factor for y coordinates. So we have 9 points here, one corresponding to each variable. And what we want to do is to rotate the axis in such a way that points are close to the axis. And we see that here, especially this first variable does not fulfill this criterion. It is not there. And where is variable number 7? There is a mistake here. Here should be 7, because we know that also variable number 7 is wrong. And here is variable number 7. So those two, first is 7, are quite far from both axes. We can try to make rotation by hand. This is the same mistake here. Let me start this. We can do rotation by hand, and it is not easy to decide which position is the best one. I've chosen such position to check whether it improved something. So our angle phi is 1.63, and we have rotated factors, and here for comparison, not rotated factors and rotated factors, and we see that there is a problem because this rotation didn't help a lot. However, we can look at those factors, and it doesn't matter not rotated or rotated, and try to interpret them. We have to forget about the first and the seventh variable. However, for example, this factor here correlates with maybe we'll start with this factor. Sorry, the second factor. The second factor here correlates with variables which are rather undemocratic. So this variable, this second variable here, says that religious authorities ultimately interpret the laws. This variable here says that army takes over when government is incompetent, and this variable says that people obey their rulers. So these are rather anti-democratic. Whether these bold-face variables are rather democratic, and there are those two ambiguous variables that have something to do with money, and they are not really associated to one of the factors. Maybe we can do better with Varimax algorithm. So now we do Varimax algorithm. For the algorithm, we need normalized loadings. So now, after normalization, which is done here, all the points are located on the unit circle. And again, what we want to do is to apply the procedure to apply the Varimax procedure to determine the angle and then rotate the variable. So I tried this procedure once. As you see here, there is all this complicated rule of associating the result of our calculations with associating an angle to the result of our calculations, taking into account the numerator and denominator signs. And after the first procedure, we see that this angle is very, very small. Yeah. So probably using two factors, we cannot do much more. I could apply this procedure the second time. Yeah, I do it the second time, and I see that this angle here is this angle. It is really very, very small now. So there is no sense making this procedure twice. As a matter of fact, once should be enough, because this is just the mathematical procedure of obtaining the maximum. However, due to numerical errors, sometimes one can do it twice. Yeah, maybe it is better. So now we look again at our factors, and what we see that maybe it is a little bit better. These are not rotated, and these are rotated. There is slightly bigger difference in the first variable. However, the seventh variable is still of ambiguous nature, and I've marked those statements in color for us to now interpret the factors. And you see that the first factor can be named democratic, because these are statements like governments tax the rich and subsidize the poor, people choose their leaders in free elections, people receive state aid for unemployment, civil rights protect people from state oppression, and women have the same right as men. And there is also this ambiguous thing: the state makes people incomes equal. And also this first variable is a little bit ambiguous. I marked it in blue, but in fact it should be probably also in orange. So you see that those two statements associated with money, they are somehow more in the group of democratic values and less in anti-democrat. Oh no, I'm wrong. The state makes people equal, incomes equal is more correlated with the anti-democratic statements. Okay, so let's come to the second factor. The second factor is composed of those anti-democratic variables. So using two factors, we cannot really do much better here. And maybe I will perform this. This is the final this is exactly our final matrix of loadings. And now we can also look at the plot. This is the final plot, and here there is a comparison of loadings before rotation, blue one, and loadings after rotation, orange one. And you see that the difference is really very, very small. So almost nothing happened after factor analysis here. So now we pass to free factors, which means that we have to add the third factor to our analysis here, and also calculate the loadings of two factors. And of course, those initial form of those two factors is the same as previously, because they are just eigenvectors multiplied by some coefficients to make those components correlations with variables. And what we have here, we have this third we should evaluate this. We have this third factor, and when we look at loadings for the third factor, we see that situation is even more complicated, because this first variable correlates with all the factors, and also not only seventh variable correlates with factors 1 and 2, but also eighth variable correlates with two factors. So here we will definitely have to do the Varimax procedure. Okay, so we start with preparing the data for Varimax. And now, okay, I have to correct a mistake here. I'm very sorry. Yeah, this mistakes is here, and also it is definitely here. I'm sorry. I will come back to explaining what is going on. Yeah, corrected. So how Varimax procedure works for more than two variables? We just do it step by step. So first we rotate, it's not, it should be in English. So we rotate two first factors, then we apply rotation to first and third, and then we apply rotation for the pair 2 and 3, and we look at the result. Look at the result means we look at angles. If the angles are very small, then we can stop the procedure. If not, we do it once more. So in a sense, we compose this rotation matrix, which now should be 3 by 3, but we compose it of several rotation 2 by 2 of two factors each time. Okay, so I start with the first Varimax. Yeah, look at the angle. Oh, the angle here is not very big. Then we do 1, 2. Bigger angle. This is the angle, and this is big. It is bigger, and we do rotation 2, 3, and also we obtain quite big angle. Therefore, we repeat this procedure, and I will go down there to check, because of course I did it before. 1, 2, 3, 4 times. I did it 4 times in previous execution of this notebook. Okay, so let me do it also 4 times. So we did it once. Now it is blue for the second time, pink for the second time, and yellow for the second time. And let's look for angles. Here this angle is not very big, and here, here it is quite, it's not very small yet, and also here it is not very small. So definitely we do it once more. Once this one and this one and this one. And now we look for angles. So we see that here the angle is quite small. Here it is also quite small. And here it is not big. Yeah, so we could stop now, but since I did it 4 times before, I will do it 4 times now. So now the angle is definitely very, very small. And the 4th time here, also very small angle. And the 4th time here, definitely very small angle. Okay, so we have the final version of final version of our loadings. Yeah. These are not loadings yet. These are the results of our calculations. The loadings will be here. Yeah, now we get the loadings because we have unnormalized. Yeah, these are normalized, and here we have unnormalized. So these are really loadings, and now we can compare these results. As you can see, there are small differences between this result and what I have here. Here I've copied I've copied the results of each step, and there are very slight differences between this matrix here and this matrix here. This probably means that there are some slight numerical errors, but the overall result is very similar. What we can see here are three factors with big loadings marked in color for every factor, and there is this one variable that remains ambiguous, and it is not associated to one factor, and probably we cannot do better using this algorithm. What we see here is that we have again this blue one factor, which is associated to democratic values. People choose their leaders in free elections. Civil rights protect people from state oppression, and women have the same right as men. So these are democratic values and abstract values. So this is the factor of abstract democratic values. This green one is practical. Governments tax the rich and subsidize the poor, and the state makes people incomes equal. So this is democratic and practical. And this variable, people receive state aid for unemployment, correlates with both this abstract and this practical factor. And there is also an anti-democratic factor, religious authorities, the army, and the people obeying their rulers. So using three factor analysis here was, I would say, successful. However, we have this one ambiguous variable, but if we forget about it, we have three, we still can clearly interpret those three factors after rotation. So I would say that this is very good result that can be used afterwards when we want to characterize political ideas the particular person has. We can, instead of looking at 9 variables, we can look at those 3 factors and composed out of those 3 variables, out of those 9 variables, 3 variables that have really well-defined meaning. Maybe I will also comment of the signs of correlations, because you see that those important correlations in the first and the second factor are positive, and in the third factor they are negative. One can always change all the signs in the factor. So we could change all the signs here, and the factor will be equally good, and we will have positive correlations. Probably, if we really want to measure the level of democratic attitude in a person, we should change this anti-democratic signs everywhere, and then we will have those red factor negatively correlating and with answers. So this means that the and those two blue and green one positively correlating. But of course these are technicalities, and one can do it when one wants to use the factors for something further. But if we only want to somehow look how it is, how the person's answers about democracy, what is the structure behind those answers, what's their thinking behind those answers, it is enough to look at the factors as they are here. And I should stop by showing you the sources. So the sources are from the Data European Values Study. If you are interested, you can read more about it. And the Varimax criterion for analytic rotation in factor analysis. It is a paper by Henry Kaiser when this idea of maximizing Varimax function is explained. Okay, so I suppose that's all. I should find a place when I stop the recording. Where I stop the recording. It's here. Okay, so it's finished.